a little simpler way of doing it.
Okay.
And in other words, the way you did it required you to find a least common denominator and proceed, correct?
Yeah.
Okay. Well, what happens if instead of doing the inside first, we apply the double exponentiation first?
Mm-hmm.
12 times 1/6 is what?
3?
2.
2. Thank you.
So
Yeah.
that becomes 10 squared. What's
Mm-hmm.
12 times 1/2?
6.
That becomes that. And now when you add them, much
That makes,
easier, isn't it?
that is a lot easier.
Notice I didn't have to find a common denominator and add those fractions. And you can do these processes in whatever order you like. You can add the 2 in the middle and then do the double exponentiation, or
Mm-hmm.
you can exponentiate it immediately. And
Okay.
in this case, because 1/6 and 1/2, when multiplied by 12, end up as whole numbers, you can
Mm-hmm.
avoid fractions altogether by doing the exponentiation first.
Okay. Cool.
Okay, let's see. What's number 8?
Number 8. So it'd just be 11 and 1/5.
11 to the 1/5 power.
Yeah.
You get a lot of students that use that terminology.
Or 1 to the 5th
That
power,
is
but
not the same as that.
no.
So you got to be a little careful. You always want to say to the power of, or if it's 2, it's squared or cubed or something. But usually fractional exponents, it's pretty easy to mix that up with 11 and 4/5.
For sure.
All right.
Okay.
How about number 9?
Number 9 would be 6 to the let's see. Yeah, -1 power. -1/7.
Uh-huh. Now give me the
Yeah.
answer with positive exponents only, which I would imagine is at the top of this page, right?
Yeah, let me see here.
Where it says
Mm,
give all
Only
answers
positive.
with positive exponents only.
Yep.
Okay. So what does this become when I turn it to a positive exponent?
Would it be parentheses 7√6
No.
to the -1? No.
Negative exponent merely means reciprocal.
Okay.
So that's the same as 1/6 to the 1/7.
Okay.
That's all you do with negative exponents.
That makes sense. Just put
Reciprocal.
over.
And it works both directions. If I have 2 divided by 3 to the -4,
Uh-huh.
even though that's in the denominator, I can just move it to the numerator and change it to 2 times 3 to the +4.
Okay.
Okay, so anytime you have a negative exponent on either the numerator or the denominator, you can just move it to the other side of the fraction bar.
Cool.
Okay.
Okay.
Number 10.
Yeah.
And,
So this
and
would.
I think it's a good idea to do these in 2 steps. You can see that you're going to get a negative exponent. So
Oh yeah.
let's write what it is before we flip it to a positive exponent.
Okay. So for 10, it would be let's see. Would you just do 1/3 times -2/1?
Yep.
Cool.
What is that?
Hold on. It'd be -2/3.
Uh-huh.
And then we would just put 1/4 over -2/3.
Not over minus. In other words, once you flip it to the
Plus,
other side, it turns it positive.
Okay, yep. Yeah, because no negative exponents. So.
Right. That's the only reason we did it. If we could live with
Yeah.
negative exponents, we'd have left it like that. And
Okay.
these are the same numbers, incidentally. They're not different
Yeah.
numbers. It's just almost every math teacher will put instructions at the top saying, give all answers with positive exponents.
Yeah.
It's kind of conventional. It's a little like not having irrational denominators.
Mm-hmm.
Doesn't change the number any, it just changes the presentation.
Right.
Now, on this one, notice that I could apply the double exponentiation first.
Mm-hmm.
I'm trying to think. It doesn't give me any advantages in this case.
Yeah.
In other words, the other problem, everything turned into a whole number when I applied the double exponentiation first on number 7.
Mm-hmm.
And that's what made it so much easier to do my way than yours.
Yeah, for sure.
This one, I'm going to end up with 3 to the minus 1/8 times 3 to the minus 1/4. Then I'm going to have to find a common denominator anyway.
Okay.
So I might as well do the inside as the first step.
Yeah, for sure.
So what is that?
3
3 to the 1/8 times 3 to the 1/4.
Well, to find a common denominator, so it would be 3 1/8 and then 3 2/8.
Okay. So give me what the inside is.
Hold on.
It's 3 to the 1/8 times 3 to the 2/8.
3 to the 2/16.
No.
Sorry, wait, let me.
When you're adding or subtracting fractions,
Oh, yeah,
the
we have.
denominator stays the same.
Yeah.
We're adding
So
here because we're multiplying the bases.
3 3/8. Yeah.
So it's not 3 3/8. It's 3 to the 3/8. Remember, those are different.
Yeah.
3 to the 3/8 is not the same as 3 3/8. 3 3/8 is a proper fraction.
Okay.
Okay. So now what?
Now it's to the -1 power, so we would just take 3/8 times minus 1 over 1.
What's my final answer going to be if I want all positive exponents?
1 over 3 to the 3/8 power.
Yep.
Cool.
And I don't actually need to multiply that by that. In other words, I know that when it's to the -1, I can put it 1 over whatever that is.
Yeah.
So I actually can save a step there by that.
Cool.
Number 12.
Yeah. Let's see here. So it would be, hold on. So it'd be 5. So 5 2, 6 plus,
And 5 2/12.
or 2/12. Yeah, my bad.
5 to the 2/12 divided by 5 to the 7/12
Mm-hmm.
is what?
So that would get you 5 to the minus 5 over 12.
Yeah, and I think it's worth doing that step right there.
Yeah.
Now what's the final answer?
1 over 5 to the 5/12 power.
Okay, good.
Cool.
Yeah, I don't think it's worth going straight to there. A lot of people would, but
You can make too many mistakes from it.
it's pretty easy to make a mistake when you try doing
Yeah.
multiple steps at once for anybody.
For sure.
But
Yeah.
number 13.
Alright. So it'd be, hold on. So it would be 7 to the minus 2 over 4
No,
times.
hold on. Make sure that when you convert that, you convert it properly. It's not 2 over 4. You've changed it if you make it 2 over 4 because it's currently 1 over 4.
For number...
So it's got to be 2 over 8.
Oh, wait, which one are you looking at? I'm looking at, 13. Okay, just make sure we're on the right one.
Mm-hmm.
So it'd be, yeah, 7 to minus 2/8 plus, yeah, plus,
Not plus, times 7 to the 5/8.
yeah, exactly.
Now what is that equal to?
That is equal to 7 3/8.
Again, you're saying end.
7 to the 3/8, yeah.
There you go. There's a world of difference between those statements.
Yeah, for sure.
I'm just going to keep correcting you when you do it, and just
Okay.
because it's important. And
Okay.
that's the final answer. That's positive exponents, so I don't need to do anything to that.
No.
Number 14.
36 to the 1/2 power.
Don't do it that way. Do the exponentiation first.
Okay. So it'd be 2 over 1 times 1/2. So that'd be 2 and 2, which is 1. So the final answer would be 6.
Huh? In other words, if you do the exponentiation first, you immediately get to that.
Yeah.
Whereas if you do it your way, you got to get to 36, and then you got to take the square root of 36. So you might not know what the square root of 36 is, but you sure know how to do it the first way.
For sure. Yeah. Cool.
Number 15.
All right.
Again, doing the double exponentiation doesn't really help.
No.
In other words, I might as well do the inside first. Only time that it really helps enormously to do the outside first is if these end up being whole numbers. In other words, I'm going to end up with 3/8 and 3/2. Well, still got to find the common denominator.
Yeah.
Okay, so we might as well do the inside. It's easier to add negative 1/8 and negative 1/2, I think. But
yeah.
So what's the inside become?
So the inside would become, so 4, hold on, to minus 1 over 8 times 4 to the minus 4 over 8.
Okay, which results in?
Minus 5/8, 4 to minus 5/8 power.
There you go. I was about to say something. You corrected it sooner. Now do the outside.
And then, so it would be 4 to the minus 15ths over 8.
Not minus. What's minus
1 over
3 times minus 5?
It's minus 3. Yeah, I did put a minus there. So that'd be positive. So 4 to the 15/8 power.
And that's the final answer because it's positive.
Yep. Okay. And then number 16 will be 9 to the minus, wait, hold on.
You're going to have to back those fractions, so you might as well come up with a least common, you might as well always convert the smaller one.
Yeah.
Notice that every one of these, you don't have to find a common denominator that's bigger than the biggest denominator.
No.
Every one of these, the biggest denominator is your common denominator. So the top is minus 1/4, and just put the bottom in fourths.
Okay.
How many fourths is 1/2?
2/4.
Now what's that equal to?
So it'd be 9 to the minus 1/4 power over 9 to the minus 1/4 power.
Hold on. You got the first part right. In other words, when I subtract the two exponents,
1/2.
Now when I put it in positive exponents, it's what?
1 over 9 to the 1/4 power.
Okay.
Cool. And then would 17 just be 5 to the 1/2 power?
let's talk about that because this is the first one we've come across like this.
Yeah.
We have different bases but the same exponent. Well, what that allows us to do is divide the bases and take the whole thing to that exponent. So the answer isn't 5. What is it?
Could you repeat that? Yeah.
What is 60 over 12 to the 1/2 power?
5 to the 1/2 power.
Exactly, which is not 5. It's square root 5. In other words, that 1/2 power stays there. It doesn't go anywhere. So the answer is 5. It's 5 to the 1/2 power.
Yeah.
Okay. Now, notice what I'm going to be able to do to here. Should I, well, first of all, I can't do the inside first.
No.
I got different bases and I got different exponents.
Yeah.
So the only thing I can really do is the double exponentiation first. So what does that produce?
Well, I don't know.
So multiply the 4 by that exponent. That's the first part. In other words, here's what I'm talking about. I'm not sure you're realizing this. If I have this, it's the same thing as writing it like this.
Okay.
And notice what's going to happen if I do the double exponentiations first. What do I get?
You just get 6.
Hold on.
How would you do that?
You seem to be having problems doing this multiplication.
Oh, times 4 over 1. So that'd be 12 over 4, which is 3.
You do not want to do it that way.
Okay.
You want to cancel the 4 with that. In other words, you want to divide top and bottom by 4, and then you end up with your answer immediately without ever dealing with a number bigger than 4. The way you did it, you dealt with a number that was 12. So immediately, when you're multiplying a number and it's got a denominator that's the same number, that's 3 to the 3rd times 2 to the 1. What's that answer?
It's 9 times 2.
It's not 9.
Or no, 27 times 2.
Okay, that's 54.
Yeah.
Okay.
Cool.
All right.
All right.
19. 19 has different base, but same exponent.
Okay.
What's another way I could write that?
Well, you could write it.
I could do
1 over 6
things, but there's one specific thing that's pretty key here, and that's writing it like this. 4 times 64, the whole thing to the 1/2. You can always do that if you have the same exponent. You can multiply the bases together as long as you include the same exponent in your answer. And that is 256 to the 1/2. And I believe that is 16?
Yeah.
Yeah, that's 16.
Yeah, that's 16.
Okay. Now, I didn't like having to take the square root of 256. That's a big number.
That is a big number.
Now, let's look and see if there maybe is an easier way to do this problem. Well, what if I wrote it like this? Actually, it is an easier way to do it.
Okay.
Instead of 64, I'm going to write 4 cubed.
Okay.
That's what 64 is.
Right.
I still have to take it to the 1/2.
Uh-huh.
Now that gives me 4 to the 1/2 times 4 to the 3/2.
Mm-hmm.
Now I got same base, so that's
Mm-hmm.
equal to 4 squared. I get to 16 a lot easier.
Yeah.
Of course, I did have to know that 64 could be written as 4 cubed, but
Right.
still, it's easier knowing that than it is knowing the square root of 256.
That is easier.
So
Yeah, much easier.
don't ignore these shortcuts, because these shortcuts, always keep in mind, keep your numbers as low as possible.
Okay.
Okay?
Okay.
Number
Cool.
20.
Alright. Let's see. Um, so this one would be 1 over 25 times 1 over 125.
No, where are you getting the 1 over? In other words, there's no
Oh, I'm
negative
looking at
exponents here.
yeah, I'm looking at the fraction word. My bad. Yeah.
It's
So,
definitely the same as problem 19.
mhm.
So you multiply the 5 times the 25 to get 125 and
Yeah.
carry the exponent forward. So it's the
Okay.
square root of 125, but that presents problems
Yeah.
because that's difficult to reduce and simplify.
Uh-huh.
You have to know that, well, 25 is a perfect square number, so
Mhm.
that's really the square root of 25 times the square root of 5,
Mhm.
which is 5 root 5 is our answer.
Mhm.
But again, without a calculator, that would have been difficult to handle that last step.
Yeah,
So
definitely.
let's go back and do it like I did the second method on 19. Let's
Okay.
rewrite 25. How can you rewrite 25?
Um,
In terms of 5. In other words, if we can rewrite this in terms of 5, then I'll have the same base, and I can just deal with the exponents.
just 5 to the second power.
5 to the 7th power is 25.
Second power.
Second power? That's correct.
Yeah. Yeah.
And now what can I do?
And then now,
Still have 5 to the 1/2 here.
uh-huh.
What's this become?
25 to 1/2 power. Well, actually, no, we could,
Don't do
yeah,
it
so
that
2 over
way.
1.
Multiply
No,
the
I won't.
exponents first.
Yeah. So that'd be 2 over 2, which is 1, so it'd be just 5.
Just 5, exactly. Notice you didn't have to deal with a number bigger than 5.
Yeah.
Now what's 5 to the 1/2 times 5 equal to?
Um, 25 to the 1/2 power.
Mm-mm. Nope. You got same base, you're adding exponents.
Oh, okay. So, 1 over
No?
1.
The answer is 5 to some power.
Yeah, so you have to do 1/2 plus 1 over 1.
Okay? What's that?
So that would be, hold on,
What's the common denominator?
2.
Okay?
So it'd just be 2 over 2, which is 1.
Okay. So you're still not done yet. You still got to give me an answer. 5 to the what?
5 to the, just 5 to the first power, and derivate that.
Oh, that's what this is 5 to the first power. What's 5 to the 1/2 power times 5 to the first power? Here, I'll make it
Um,
easy. I'll write 1 as 2 over 2. Now do
yeah. So 3 over 2.
it. Okay.
5 to 3 over 2 power. Okay.
Ah, and that is the answer. And notice
Mhm.
that 5 to the 1/2 power times 5 to the 1 power is 5 root 5.
Cool.
That's the same as that.
Yeah.
I just got it a lot easier doing it this second method. Never
Hmm.
once dealt with a number greater than 5.
No.
Whereas up here I had 25 and I had 125.
Yeah.
So far easier to do it the second method.
For sure. Yeah. Okay.
What was that? That was 20, wasn't it? Yeah.
Yep.
All right, let's do 21.
Cool.
What's 21 going to be?
So 21 is going to be
Different
4
base,
to the
same
1/3 power.
exponent. Different base, same exponents. What's the answer?
Yeah. 4 to the 1/3 power.
Good. 22.
So 22 will be, um, let's see, 25 to the 1/2 power.
Well, where are you getting that? It's
Or 1,
125 to the
1/3.
1/3 power.
Yeah, so 5 to the 3rd power.
No? Well, okay. I see what you're doing.
5. Yeah, 5 to the
There's
3rd.
actually a really easy way to do this problem. You just
Is
got to
there?
see it. In other words, here's the hard way.
Mhm.
125 times 64 all to the 1/3 power. That's certainly correct. I can do it that way.
Mhm.
But I'm going to need a calculator.
Yeah.
Okay. What's the
Okay.
third root of 125?
5.
Ah.
Mhm.
What's the third root of 64?
4.
Answer is 20. Never
Okay.
dealt with a number bigger than 20.
That's really easy.
Mm-hmm. A lot of the times the trick on these things is just knowing which method to use. And
Yeah, for
all
sure.
of them are valid. It's just some are easier than others.
Yep,
Now,
exactly.
immediately when I look at 23,
Mhm.
I'm asking myself, well, I can't do anything with the inside because I got different base, different exponents.
Mhm.
The only thing I can really do is the double exponentiation immediately. That's
Yeah.
got to be my first step.
Mhm.
So what do I get?
Um, let's see. 7. Well, so 7 to the 4/5
Where you get
times
4
12.
over 5. Okay. You're adding those, but you can't do that because they're different bases.
Oh,
If
that
that was
makes sense.
7 to the 3/5, you could do that.
Can
But
you do that?
you decided, no, it's different bases, different exponents. You can't do anything with that expression inside the parentheses.
Mhm.
But you can multiply 5 by that exponent, so you get what? 7.
Um, 7 to uh
This gives you problems, and I'm not sure why.
times. Yeah, so it cancel out the 5, so it'd just be 1.
Yeah.
Yeah.
Okay, so it's 7 to the 1
Mhm.
times what?
So it'd be 7 to the 1 times 2 to the 3rd.
Yeah. Notice how much easier those manipulations are if you cancel first.
Yeah, that's really easy.
You would have been inclined to say 2 to the 15/5,
Mhm.
and then it would have taken another 10 or 15 seconds to reduce that to 3.
Yeah.
Well, always be simplifying before you multiply these fractions, if
Cool.
you can.
Okay.
And then
Yeah.
now you can come up with that. What's 2 to the 3rd?
12.
Mm-hmm. It's 2 times 2 times 2.
2 times 2 is 4 times 2 is 8. My bad. Yeah.
So it's 7
Mhm.
times 8.
Is 56.
Okay.
Cool.
Now, the very first thing I notice about this is that
Mhm.
doing the double exponentiation is going to be a great way to go because I'm
Yeah.
looking at two denominators that are both 2.
Uh-huh.
And I'm multiplying by 2. Not only that, but I can't really do anything with the inside because I got different bases and different exponents. So I
Mhm.
really have to do the double exponentiation first. So what does that
Yeah.
leave me with?
So 4 to the 3rd times 1 to the 1st.
Yeah, there you go. Now you're
Yeah, now
figuring
it's
out
going
how
good.
to multiply those fractions.
Yeah.
Same thing on 25.
Okay. Yep. So we would do 2 to the fourth times 9 to the second.
Yeah. 2 to the fourth is what?
2 times 2 is 4 times 2 is 8 times 2 is 12.
2 times 8?
16.
You know what? It's a good idea to remember 2 to the powers all the way up to like 6 at least.
Yeah.
It's a good idea to know that 2 to the 6th is 64. Just
Okay.
from memory. In other words,
Yeah.
without having to multiply it all together. What's 9 squared?
81. And
We're
then
going to need a calculator, and there's no way
yeah.
to operate a calculator here.
I got 1,296.
Yeah.
Yeah.
I like to be able to solve problems without a calculator if I can, just because it's really valuable to be able
Uh-huh.
to do that. And the secret is to simplify first. But
Yeah.
in this case, I have such big numbers that I can't avoid that big number right there.
Yeah.
All right.
Sweet.
Well, you seem to be pretty good with these, actually.
Yeah, I feel pretty
Yeah,
confident about
I
them.
think you'll
So
do fine with these.
yeah, me too.
All right, Dylan. So
Sweet.
we're going to keep Monday and Wednesday at 8.
Yep, let's do that.
Okay.
Yeah, I have baseball Tuesdays and Thursdays, so we'll just
Okay.
keep what
Sounds
we're
good.
doing now. All right.
Well, enjoy your baseball, and I'll talk to you next Monday.
Sounds good. Thank you, Mr. Cowan.
Bye-bye.
Cool. Bye-bye.